Hello everyone, I'm Vibhor Singh, and today we'll be discussing the 24th problem of the CP-31 sheet under the 1300 rated parameter. So as you can see, this is the CP-31 sheet and the 1300 rated problems have been selected, and this is the 24th problem, just eat it. Today Yasser and Adil are at the shop buying cupcakes. There are n cupcake types arranged from 1 to n on the shelf, and there are infinitely many of each type. The tastiness of a cupcake of type I is an integer AI. There are both tasty and nasty cupcakes, so the tastiness can be positive 0 or negative. Yes, sir, of course, wants to try them all, so he will buy exactly one cupcake of each type. On the other hand, Adel will choose some segment L, R, where L and R should be between 1 and n, that does not include all of the cupcakes. He cannot choose L, R equal to 1, n and buy exactly one cupcake of each types from L to R. After that, they will compare the total tastiness of the cupcakes each of them have bought. Yesser will be happy if the total tastiness of the cupcakes he buys is strictly greater than the total tastiness of cupcakes Adel buys regardless of Adel's choices. And we have to find if Yesser will be happy after visiting the shop. So let's try to understand the problem. Let's take the second example, 3, 7, 4 and then minus 1. Right, so 3 is n, that is the number of cupcakes we have, and then 4, 7, 1, 4, 7 and minus 1 rather are the tastiness of each of these cupcakes. Now, there are two people, Yesser and Adel, who will be trying these cupcakes. Yesser will try all the cupcakes. So total tastiness would just become sum of tastiness of all the cupcakes. So Yesser would have a total tastiness of 10 after trying all the cupcakes. Adel, on the other hand, can choose any sub-array from this array. That is, he can choose any sub-array of these cupcakes and taste all of them. So the tastiness for Adel will become the sub-array sum for the segment he chooses. Okay, so something like for him, a possible segment could be 4, a possible segment could be 7. So this is like 1, this is another thing. A possible thing could be minus 1. He could try 4 comma 7, that is this subsegment, right, this subarray, and so on and so forth, right? But he cannot try something like this. He cannot try the entire array, right? So he cannot try all the cupcakes present. That is the constraint given to us. Now what we have to see is that if, so it states that if it is possible, see, Yesser will be happy if the total tastiness of cupcakes he buys is strictly greater than the total tastiness of the cupcakes Adel buys regardless of Adel's choices. So since Adel has so many choices, now Yesser will be happy only if whatever choice Adel makes, Yesser's tastiness or the tastiness Yesser will taste is higher or strictly greater, like it is higher than whatever tastiness Adel tastes, right? So if, in this example, if Adel chooses this, that is this subarray of 4 comma 7, his total tastiness would become 11, right? And since 11 is greater than 10, our answer over here will just become no. Okay. And on the counterpart, if you look at the first example, where we have 4 and then 1, 2, 3 and 4. So this is the first example or first sample case that we have. In this sample case, if we see, total of Yesser's tastiness would become 10, right? Sum of all these values, and total of Adel's tastiness. Now Adel cannot choose all these values together, right? So he cannot get 10, right? He cannot get 10. He cannot get 10. The maximum he can get is maybe if he chooses these three, that is the last three values together, that's the subarray consisting of the last three values, and the maximum tastiness he'll get is 9. And since 10 is greater than 9, 10 is strictly greater than 9, we can print yes for this case, that yes, irrespective of whatever subarray Adel chooses, Yesser would have a total tastiness greater than Adel's total tastiness. So that is what the problem states. Now let's move on to the expected time complexity discussion. The total number of test cases are till 10 raised to 4, n goes till 10 raised to 5, and it is guaranteed that sum of n overall test cases doesn't exceed 10 raised to 5. So we know 1 second in Codeforces corresponds to approximately 10 raised to 8 operations. Now we know n is given to us till 10 raised to 5, or sum of n overall test cases given us to 10 raised to 5. Now anything of the order of n or order of n log n or order of n root n should work. But if we go in anything of order of n square or greater, that will lead us to getting TLE. So that's it for our expected time complexity discussion. Now let's try to form a solution to the problem. Now, yeser's overall tastiness is fixed, right? That is going to be sum of entire array. Now, let's try to see maximum tastiness Adele can get. Okay, let's try to calculate this part. Okay, so since Adele chooses sub-arrays from the array, that is, we have some array, Adele will choose some sub-array, right? He will choose some sub-array. So Adele's maximum tastiness that Adele can get would just become maximum sub-array sum. Right? Maximum tastiness that Adele can get will just become maximum sub-array sum of our array. Right? Now, once we have the maximum tastiness Adele can get, as long as we have the overall sum, that is yeser's tastiness, greater than the maximum sub-array sum, that is Adele's maximum tastiness Adele can get, then our answer would be yes, right? And if this condition does not satisfy, our answer would become no, right? So the only problem or the only thing that we have to keep in mind is that while calculating the maximum sub-array sum, we cannot take the entire array as a whole, right? For maximum sub-array sum, we can always use Codeforces algorithm. It's a very standard method and we can calculate maximum sub-array sum. But we have a constraint that we cannot choose 1 comma n for our overall sub-array sum, right? And even without choosing 1 comma n, it is possible to get some sub-array sum or a sub-array sum equal to the overall array sum. For an example, if we just look at an array having 3 values, 5, -5 and 5, okay? If you look at this array, the overall sum becomes 10, right? Overall sum is 10, sorry, overall sum becomes 5. So, yeser's tastiness would become 5 overall sum. Now, Adele can choose either this 5 or this 5 alone and still get total tastiness as 5 for Adele without choosing the entire subarray as a whole, right? So, we can get equal to as well even when we don't choose the entire array. So, how do we handle this one specific condition? There can be many ways to handle this. One way to handle is, since we are calculating subarray sums, maximum subarray sums, we will perform it in two parts. That is, once we'll run it for 1 comma n minus 1. That is, we won't run our maximum subarray sum algorithm using Codeforces algorithm. We won't calculate it for the entire array. We will calculate it for 1 comma n minus 1. And then the second time we'll calculate it for 2 comma n. Okay, that is considering one base indexing. First time we will take all values except for the last value, and the second time we will take all values except for the first value. So like this, we are covering all the possible sub arrays that Adele can choose, right? See, if you have an array, let's say 1, 2, 3, 4, 5, right? So maximum subarrays that Adele can choose can either be like this, that is from 1 to n minus 1, right? Or anywhere in between. It can be anywhere in between. But if the subarray includes the first element, then the last element that subarray can include would be the second last element of our array, right? Because Adele cannot choose first and last elements together. And similarly, if we include the last element in our subarray, then the maximum starting value could be the second element of our array, right? Because we cannot choose the entire array together. That is why taking these two segments as separate parts in our Codeforces algorithm, we can just avoid that 1 comma n, or the case for 1 comma n being L comma R, will never be taken, right? It will never be taken, and all other cases will get covered by choosing this type of combination. That is, first we calculate maximum subarray sum for 1 comma n minus 1, second time we do it for 2 comma n, and then the overall maximum subarray sum that we'll get would be the maximum tastiness that Adele can get. And if maximum tastiness of yeser is greater than maximum tastiness of Adele, then our answer is yes, else our answer is no. Okay, so this is our entire algorithm. This will be our entire algorithm. We'll apply Codeforces algorithm for 1 comma n minus 1 and then 2 comma n, and then we just get the maximum subarray sum over both these iterations. And if that value is less than the overall sum of our array, then our answer is yes, else the answer is no. So let's move to the code of the problem. First, we take n as input, then the array of length n as input, and then we initialize sum to be 0. I've taken it long because we are given that e of I goes to 10:9. So that's why we are taking sum as long. And we are calculating the overall sum while taking the input itself. So while taking the input, we calculated the overall sum or the tastiness of yes sir. Right. Now, to calculate the tastiness of array, initially we are taking maximum subarray sum as 0 and current sum as 0. This is very standard cadence algorithm. First time we are applying it from 0 to I less than n minus 1, right? So we are excluding the last value of our array from our subarray sum calculation algorithm. We increase the current sum. If the current sum is negative, we make it 0. And then we just make maximum subarray sum to be maximum of, like, we just maximize our maximum subarray sum with the current value. And then again, we create or we set current sum as 0 again, and then we perform our cadence algorithm again for 1 to n, right? That is, we'll exclude the first value of our array. And again, the same entire algorithm. And in the end, if the maximum subarray sum is greater than or equal to sum, then our answer is no, else our answer is yes. So that's it for the problem discussion. Let's discuss now. Let's see the time complexity of a solution, right? So overall time complexity of taking the input will be order of n. The time complexity for running or for calculating subarray sums using cadence algorithm would be order of n itself, right? There's no extra complexity that is used in this, and then in the end we're printing using if-else statements. So overall time complexity will just become order of n, right? Or sum of n overall all test cases, which is well within the bounds. And the overall space complexity, we have taken an array of length n as input, and then there's no other extra space in our solution. So the space complexity also becomes order of n. So that's it for our solution discussion. I hope you were able to understand it. Thank you.